Hey guys, coming over your surface area study guide. I would suggest you do the whole study guide first and then go through this video when you're ready to check any questions that you missed or want to check. So go ahead and do that now and then come back when you're ready to check. Let's get started with number one. It says we have a cube and it's being wrapped in shrink wrap. So anytime a 3D object is being wrapped, this is a question about surface area. And I know this is a cube, so I know that since one of those sides is 3 inches, all the sides are 3 inches. And a cube is made up of 6 squares. So this is one of those squares. It's a 3 by 3. And if I want to find the area of a square or any rectangular parallelogram, I do base times height. 3 times 3 is 9. And there are 6 of these. So 6 times 9 is 54. So there's 54 square inches for this game cube. At this point, I want to make sure that I've reread the question and answered what the question needed to know. The question says how many square inches of shrink wrap will be used to wrap 5 game cubes. Since 54 square inches is the surface area of one of these game cubes, and I want to wrap it 5 times, I'm going to do 54 times 5. And that gives me a final answer of 270 square inches. Let's look at number 2. We're finding the total surface area of this figure. This figure is the net of a triangular prism. I can tell from the picture that all 3 of these rectangles are going to be the same dimensions. Each one of them is a 9 by 6. So I'm finding the area of each one of these rectangles. Area of a rectangle is base times height. So 9 times 6 is 54. So I just wrote 54 inside each of those rectangles. The other shape that we see is a triangle, and there's 2 of them. So we need to find the area of each of these triangles. For a triangle, we're going to use the formula 1/2 times the base times the height. I can see from the picture that the base of each triangle would be 6 centimeters, and each triangle has a height of 5.2. When I multiply these numbers out, I find the area of one triangle is 15 and 6/10 square centimeters. Now I know that there's 2 of these triangles, so I found the area of one. I need to find the area of both. They're the same, so I'm just going to double this number, which gives me a combined area for the triangles of 31.2 square centimeters. And since I'm finding the total surface area, I'm going to take the area of the rectangles and the area of the triangles, and I'm just going to add those numbers together. When I do that, I get the total surface area of 193.2 square centimeters. Number 3 is asking you to find the lateral surface area of this equilateral triangular pyramid. I know that this is a net of a triangular pyramid. I know that lateral surface area is the area of all the sides of a 3D shape except for the bases. So the base of this triangular pyramid would be one of the triangles. So I can just knock one of these triangles out. I'm not going to take the area of one of those triangles. And since it's equilateral, I know that all those triangles have the same dimensions. I need to know the surface area of this shape. So I'm going to use the formula for area of a triangle, which is 1/2 times the base times the height. The base is 12, the height is 8. So I plug in my values, and I found that a single triangle in this pyramid has 48 square feet as its area, and there's 3 of these triangles that have the same dimensions. So I'm going to multiply that number by 3 and find my total surface area for all the faces except for the base, which is what lateral surface area is 144 square feet. Number 4, I'm going to do just like normal because it's asking me to find the total surface area of the square pyramid in square inches. So surface area, square inches, I know I'm going to need to find some area here. Since it's a square in the pyramid, this is an 8 by 8. It's got the same dimensions on both sides. So an 8 by 8 square has an area of 64 square inches. I circle it and write it in there because I know at the end I'm going to need to add up the things that I circled. So I also see some triangles, and I know I need to find the area of each of these triangles. So I'm going to use the formula 1/2 times the base times the height. The base would be 8, and the height would be 9. So I'm going to plug in my values. And when I simplify this, I end up with an area of 36 square inches for just one of the triangles. So you can put 36 in each one of these triangles, and then you can add them up. Or I think it's a little bit easier to say since there's 4 of them and they're all the same, we can just multiply 36 times 4. So I would take 144, which is the total area of all the triangles, plus the 64, because that's the total area of the square. And now I find the area of all the faces. I need to add those up to find total surface area, which gives me a total surface area of 208 square inches for this square pyramid. For number 5, I'm going to find the total surface area of this rectangular prism. and I'm looking at a net of it. In a net, you're looking at the flattened version or unfolded version of that 3D shape. So I can see that I've got 6 faces. There are 6 rectangles to find the area of. Let's start with these 2 sides. They're the same rectangle, and they're both 6 by 8. So since they're 6 by 8 and they're rectangles, I'm going to use the formula base times height to find the area of these rectangles. 6 times 8 is 48. So I'm going to find the area of each of these rectangles and put it in the box at the end. I'll add them all up to find the total surface area. Let's look at 2 other rectangles that have the same dimensions. If I was going to fold this rectangular prism back up, that would be the top and the bottom. And I can see that they have side lengths of 15 by 8. So 15 by 8 gives me an area of 120. And like I said, it's going to be the same for both of them. Now let's look at that last 2 rectangles, the front and the back. These are a little bit harder to me. I can see that they have a side length of 15. But if I want to know their width, if I folded this back up, the 6 right here would fold back up with this. So this is a 6 by 15 rectangle, which gives me an area of 90 for each one. The thing with these rectangular prisms is if there's 3 different numbers, you should have really 3 different measurements. So I have 48, 120, and 90. If you have 2 or more that are the same, that doesn't make sense with our dimensions since all 3 of these numbers are different. So that's just one way to check yourself whenever you look at these. Now I'm finding total surface area of this shape, so I know that I need to take all these areas and add them all up, which gives me a total surface area of 516 square meters. For number 6, your job is just to sketch a net that will not result in a cube. So you could sketch the square pyramid here. You could sketch the triangular pyramid here. You could sketch this triangular prism here because all 3 of those nets that we've just looked at do not result in a cube. So your answer could vary for this one. Number 7 is kind of a really scary looking word problem. So I'm going to take what I see in there, and as I see it, I'm going to label it and draw it onto these 2 pictures. So it says I have a square pyramid, that's this right here, and a cube. So I've drawn those pictures out. And what I know about those 2 shapes is that they have the same surface area. The length of each side of the base of the square pyramid is 10 feet. So I'm looking at the base, the square of the square pyramid. I'm going to label each one of those with 10 feet. And then it tells me I have a cube that has a width of 6 feet. So a cube has each one of these side lengths of 6. And since it's a cube, they are all the same. Now, the question wants to know what is the slant height of the square pyramid. So for the pyramid, there's triangles on it. It just wants to know what's the height of one of the triangles. So let's start with what we know. I know that I can find the surface area of the cube because if I have one of the sides of the cube, I have them all. Since the square is a 6 by 6, I can use base times height and realize that the area of one of those faces is 36. And there are 6 faces on a cube. So I'm going to take that 36 times 6 to get a total surface area for the cube of 216 square feet. Now I know that the square pyramid has the same surface area as the cube. So this square pyramid has a surface area of 216 also. So let's take what we already know for the square pyramid and let's plug that into some sort of an equation. So I know that the base of the square pyramid is a 10 by 10. So I know that the bottom part of the square pyramid already has an area of 100 square feet. I know we're going to take that and we're going to add that to the area of the 4 triangles. And each triangle has the area formula for 1/2 times the base. And we have the base. So I don't need to write B, I can put 10. And we're missing a height. We don't know the height, and that's what we're solving for. Anytime that you're solving for something that you don't know, and it says something like the same as, you're setting up an equation. This is the equation I would use to set up this problem. The square pyramid has an area of 100 for the base, plus the 4 triangles, and each triangle has the formula for 1/2 times the base of 10 times the missing height. And that's going to be the same as the 216 area of the cube. When you got your equation set up, you can solve this. I'm going to look at the left side and see if there's anything I can simplify. So I'm looking in parentheses, and I can see I can take 1/2 of 10. 1/2 of 10 is 5, and then I'll bring everything else down. I'm still looking at the left side. I can simplify this another time because I can take 4 times 5h, which is 20h, and then bring everything else down. And now I'm looking at a 2-step equation. So I'm going to take off the 100 from both sides, which again, that's the base area, which we can take off because we know that's already there, leaving me with the 1-step equation. 20 times the height equals 116. I know I need to get the height by itself, so I'm going to divide both sides by that 20, which gives me a height of 5.8. So you should circle B. Let's look at number 8. It says the pyramid pictured has a total surface area of 36 inches squared. So we know the total surface area in this one, and we're finding the missing height. So if you have a total and you're missing a part of something, you need to set up an equation. Let's look at what we already have for our equation. I know that the base is a square and it's a 12 by 12 square. So I already know the area of that is 144. So I'm going to start with that. Plus, there's 4 triangles, and each one has the same area formula, 1/2 times the base times the height. So I can already do half the base, so half of 12 is 6. And I did that because that's the formula for area of a triangle. We don't know the height, so we're going to take times x. Since we don't know the height and that's x, we're going to put in an x for the height. That is going to equal altogether 336 because that is what the surface area in total is for this square pyramid. When I have this equation set up like this, I can go ahead and solve it. So do that now if you haven't already, and then press play when you're ready to check. I look on the left side, I can do 4 times 6, so I'm going to make that 24x and bring everything else down. Now I have a two-step equation. I need to get rid of that plus 144, so I'm going to subtract 144, and if I do it to one side, I have to do it to the other side, leaving me with a one-step equation. 24x equals 192. Since it's 24 times x, I'm going to get rid of that times 24 by dividing by 24. I'm going to do it to both sides. So I got that x equals 8. In the context of the problem, I just found that the missing height of that triangle is 8. So you could check this by plugging that 8 back into the formula for this, find the area of these triangles, and then add those with that 144 base, and you should end up with 336. Again, that's just a strategy to check that you did all your work right. For number 9, we're going to find the surface area of the 2 rectangular prisms, and then we're going to compare them because it wants to know which one has the greatest total surface area, so which one has more. Let's start with the one on the left, A. I'm going to start by finding the surface area for the top and the bottom. The top and the bottom have dimensions of 12 by 6, so I'm going to write 12 by 6, and I'm going to double it. The sides in red are 6 by 6, so I'm going to find the area of one of those and then double it. And then there's a front and a back, which have dimensions of 12 by 6. So I'm going to write 12 times 6 and then double it. So this is the area of the top and bottom, sides, and front and back before I double it. I need to times each one by 2 because, like I said, there is 2 of each of these faces. So in total, I have these 3 numbers for my areas. Now to find the total surface area, I just add those together. So I have a total surface area of 360 square inches for just the rectangular prism A. Now we need to do the same thing for rectangular prism B. So let's look at the top and the bottom. The top and the bottom for B have dimensions of 15 by 6 rectangles, and there's 2 of them, so I'm going to double it. For the sides, I see that there are 2 6 by 3 rectangles, so I've got 6 by 3, and like I said, there's 2 of them, so I'm going to double it. And then there's the front and the back rectangles, which have dimensions of 15 by 3. There are 2, so I'm going to double it. Now I'm just going to use my calculator to type these things in. 15 by 6 is 90, times 2 is 180. 6 times 3 is 18, times 2 gives me an area for 36 for the sides. And then 15 times 3 times 2 is 90. And now I need to find the total surface area for B. So I'm going to add these 3 numbers together, which gives me a total surface area of 306 square inches. The question wanted to know which one has the greatest total surface area. That would be A. 360 is bigger than 306. Number 10 is a tough one. It says the surface area of a cube is 390 square centimeters. We're trying to figure out what one side of that cube is going to be. So I put that as an X. We don't know what it is, but we know it's the same on every side because it's a cube. I also know that the area for a square is going to be base times height. And I know that there are 6 faces for the cube. So I know that I can do X times X, and that's going to give me the area of one side. And I know, like I said, there are going to be 6 of those that are the same. In total, that surface area is going to equal 390. So that's how I get my equation. I'm going to look in the parentheses. I see X times X is the same thing as X with an exponent of 2 because that exponent means that it's being multiplied by itself. I know I'm looking at a 2-step equation. I draw my line down the equals, and I need to get rid of that times 6 before I deal with the exponent. So I get rid of that times 6 by dividing both sides by 6. So I get some number times itself equals 65. Remember, when I solve an equation, my goal is to get the x by itself. Right now, it's not because it has that exponent of 2. And we solve equations by doing the inverse operation. So I'm doing the opposite of squared. The opposite of squared is a square root. And that button is on your calculator. And if you take the square root of 65, you end up with a number 8.06, and it goes on. So the one that matches is a number between 8 and 9. C. Number 11 is a question about a shoebox being covered with packing paper. It talks about something per square inch. So I know this is a question about surface area. So I know I need to find the surface area for the shoebox. And then I'm going to find the cost per square inch. And then I'm going to figure out how much it costs to cover 3 pair of shoes. So I won't be done until I figured that out. But the first thing I need to do is find the surface area for this box, since it says it's being covered with packing paper. So I'm going to break this down into a net. The top and the bottom are 14 by 8 rectangles, and there are 2 of them. So I'm going to do 14 times 8, and then I'm going to multiply that by 2. For the sides, they are 4 by 8 rectangles, and there are 2 sides to this box. And there's a front and the back to the box. So the bottom is 14, and that side is 4. So you got 2 14 by 4 rectangles as well. So you calculate these. The top and the bottom have a total area of 224 square inches. The sides have a total area of 64 square inches. And then the front and the back have a total area of 112 square inches. To find the total surface area, I need to add these areas together, which gives me a total surface area of 400 square inches for the shoebox. Now, I'm not done yet because the question's asking about cost, and it tells me that the paper costs 2 cents per square inch. This is how many square inches I have. Since it costs 2 cents per square inch, I'm going to multiply that 400 by 0.02. That's going to tell me how much it costs to ship 1 pair of shoes, which is $8. So it costs $8 to ship and cover 1 pair of shoes. But the question is asking me to find how much it costs to cover 3 pairs of shoes. So I take that $8 per one and times it by the 3 that it's going to be covering to get a total cost of $24. Number 12 looks like a really crazy problem about rectangular prisms and a total surface area. You got all these numbers. Let's not get crazy. Look at this rectangle in red. You have a 24 square inch area, and you have a 3 by x. You do not know what x is. Your job is to figure out what x equals. But you know that 3 times x gives you 24. All you need to do is solve this one-step equation. So divide both sides by 3, and that tells you that x equals 8. That's it. All right, guys, that's it for your study guide. If you need any help, please let me know. If you're good, great. Good luck on your test.